Good morning, everyone. This is for MSc Physics entrance test. Those who are preparing for PG entrances, I am going to take some classes. In this video, we mostly concentrate on equivalent circuit problems. So many MSc entrance tests they ask problems on equivalent circuit problems. There are some tricks to solve those problems. So they are very easy if you know the concept. Okay. సో ఇది మోస్ట్లీ ఎంఎస్సి ఎవరైతే ప్రిపేర్ అవుతున్నారో వాళ్ళ కోసం ఈ వీడియోస్ తయారు చేస్తున్నాను. ఐ విల్ మేక్ మోస్ట్ మెనీ వీడియోస్ like I will take some concepts. I will try to explain you in simple manner. Okay, mostly I will explain you tricks only. Okay, so today's topic is equivalent circuit problems. If you see in Hyderabad Central University, when they conduct MSc entrance test, they usually focus on electrical circuit problems. They will give some electrical circuits and they will ask you what is the equivalent resistance between point A and point B. Similarly, they have asked many problems like here equivalent capacitance you have to find, and also equivalent resistance in a cube, equivalent resistance in a prism, okay, pyramid or something they have given. So I will tell you some tricks so that these problems are very easy. Before that, we should know that what happens to the resistance when they are connected in series. Okay, when they are in series, we know, and there are two resistors which are connected in series, the equivalent resistance will be R1 plus R2. Similarly, if it is parallel, what happens? R1 R2 by R1 plus R2. We will use these two problems. Remember, when they are in series, this is the problem, and this is the formula. When they are in parallel, this is the formula. Okay, so see the first one. They have given some electrical circuit here, and resistors are connected in this manner. Upon seeing, you cannot say whether they are in series or whether they are in parallel. Okay, so we have to identify which resistors are in parallel, which resistors are series. Okay, here we are going to use two tricks, two concepts here: point potential function, point potential method, okay, technique. Second is mirror axis method, okay, or symmetry of axis or something. Some people say mirror axis or symmetry of axis system. These two methods we are going to use. Okay, first of all, point potential means suppose there is some resistor here like this. Okay, so point potential means if this point has potential VA, okay, at point A the potential is VA, let's say, up to wherever the straight line, ఎంతవరకు straight line ఉందో, up to there you will have the same potential along the line. Whenever you find some resistor, then the potential will change. At this point will be some other potential like VB. Okay, so this is called point potential, means wherever you see the straight line, the same potential will continue. Whenever you see resistor or capacitor, potential suddenly changes to the next point. Okay, so ఇంతవరకు same potential ఉంటుంది, suddenly resistor వచ్చింది కాబట్టి after resistor you will find a new potential. Okay, so this is called point potential. Okay, mirror axis means you see symmetry ఉండాలమ్మా ఏదైనా circuit. If the circuit is symmetry, then only you can use the symmetry of axis or mirror axis. Okay, here if you see, if I draw some mirror at this line, exactly this circuit looks like the same circuit, though values are different, they look like a symmetry. Okay, so this axis is called symmetry axis or mirror axis. Okay, because this is a mirror image of this one. Now what I have to do here, one point is in mirror axis method, the main important point is on the symmetry axis. Okay, on the symmetry axis, on the axis I am writing instead of symmetry, on the axis. Okay, potential will be same. This is the important, very important point. Potential is same. What is the point? This is the very important point. If you don't know this one, you cannot solve this problem. So on this axis, which is making the symmetry axis, okay, throughout this line the potential will be the same. Okay, so if potential is same means what? Let me about this one. Okay, so this point is symmetry, this axis is symmetry, so this is the symmetry axis. So throughout this potential is same, even though resistor is there, same potential. Same potential means no current flows, right? Current ఎప్పుడు flow అవుతుంది when there is a potential difference, current flows. But this symmetry axis is having the same potential, so there will be no current through the resistor which is in this line. Okay, so point, what is the important point we got it now? So on the symmetry axis, since they have same potential, no current flows through the resistance. That means the resistor unna okate lekapona okate, so there is no use of this resistor. Simply they have given for confuse you. Okay, so there is no use of this resistor, so we can neglect this resistor because this is having the same potential. Okay, no current flows, that's why we are neglecting this resistor. Okay, now I will identify according to the point potential method. I will identify the different potential parts. Okay, so this is A. So up to this point we will have same potential. So A, I am writing VA badulo I am just writing A. Okay, so since this is B, so up to this point there will be a B. Okay, since we are getting resistor suddenly, so next will be potential will be changed. So let's say this is C, up to this will be C, again up to this C, again up to this point potential will be C. Okay, and I already told you this is a symmetry axis, so let's say let this point will be C, same potential throughout this place. So E point kuda it will have a same potential. Okay, so ikkada D undante, so up to this also D, same potential, up to this also D. Okay, up to this point same potential D, up to this point same potential D. Okay, let's say D నుంచి సడన్ గా చేంజ్ అయింది కాబట్టి, so let's say this is E. Okay, E, so this point will be E, this point will be E, so up to this point will be E. Okay, so we got 5 different points A, B, C, D, E. Okay, so now I will make them in different in this manner. Let me clear these drawings. Okay, so I will write down here whatever the points I got on this circuit. So you will see a very beautiful manner. So let's say A and B. Okay, so A, B, in between we are getting C, D, E also. So let me write. So first I am getting C. Okay, so C, D, E, B, because I am coming from A, C, D, E, B, right? So A to C, how many resistors are there? Only one. This is the one. So I will just put one resistor which is having 1 ohm. Okay, now find out how many resistors are in between C and D. C to D 1, C to D 1. Okay, and any else 2. Okay, 2 resistors are there. So can I write 2 resistors which are having 3 ohm and 5 ohm. Okay, and how many resistors are in between D and E? D and E 1, D and E 2. Okay, there are 2 resistors again. Okay, so this is E point. Okay, so which is having 9 ohm and 15 ohm. Okay, now how many resistors are in between E and B? Only one, so which is nothing but 1.5 ohm. You see now you got very clear. This is in series with this parallel circuit. Again, this is in parallel. This is again series. So we know the formulas here. So parallel circuit equivalent resistance ఎంత అవుతుంది ఇక్కడ 3 ohm 5 ohm substitute చేస్తే ఎంత అవుతుంది 3 into 5 by 5 plus 3 8. Okay, that means 15 by 8. This one will be 9 into 15 by 9 plus 15 anta 24. Okay, 3 3s are 3 8s are. Okay, 45 15 this is 15 by 8. Okay, plus this is 45 by 8. Okay, plus 1.5 because it is in resistor, and there is 1 ohm also. Okay, now find out how much this will be. 60 by 8. Okay, 60 by 8 means how much? You divided by 60 by 8. Let me find out the answer. So 60 by 8, you will get 7.5. Okay, 7.5 plus 1 8.5, 8.5 plus 1.5 10. Okay, so you got finally 10 ohm resistor. This is the final answer. Okay, so this is how you have to do this problem. So final answer is we got around 10 ohm resistor. You got the, so what we have done is we have used the symmetry axis, so that this point and this point will this point and this point will have same potential. So we have identified different potentials and made them in series and parallel connection. And also there is simple trick, no need to doing that one also, since this is a same potential. Okay, whenever you draw, so whenever you draw a symmetry line, okay, symmetry line, if this is and this are symmetry, then what you do, you just simply remove this point connection. Okay, that means the net diagram will be something, it will be look like. Okay, and there is one more resistor here. Okay, and this is one more resistor, and this is one more resistor. So I just removed the in center part. Okay, what happened? This is 1 ohm, this is 3, this is 9, this is 5, this is 15, this is 1.5. See, both are in series. 9 plus 3 12. Okay, so 1 plus 12. Okay, so let me input. So this and this are in parallel connection, right? So 12 parallel to 5 plus 15 and the 20. Okay, plus 1.5. Okay, so 1 plus 12 resistor 20 resistor parallel connection చేస్తే 12 into 20 by 32. Okay, 12 plus 20. So what happens? 4 8s are 32, 4 5s are 20, again 4 2s are 4 3s are. Okay, 15 by 2, 15 by 2 is nothing but 7.5. So 7.5 plus 1.5, so finally we'll get 10 ohm. Okay, this is also one method you can easily do instead of doing earlier one. So this is very simple. Whenever you see a symmetry line, you just remove that connection from the circuit, so that you will come to know whether they are in series or parallel. Okay, very easy method, right? This is very easy as compared to previous one, but previous one is also a good method. You can follow any kind of problems. Okay, so next question, come to the next question. We have to find the equivalent capacitor between A and B. See this problem also we will go point potential method. Okay, so each point దగ్గర ఎంత పొటెన్షియల్ ఉంది అన్నది ఐడెంటిఫై చేస్తూ we will find out. Before that, let me make you another circuit diagram. So see, this and this both are in series. So instead of taking 2, I will take it as a one equivalent circuit. Okay, so in capacitors lo series ki formula emotudi, C1 into C2 by C1 plus C2. C parallel ఏమవుతుంది C1 plus C2. So we will use these formulas. Okay. So ikkada both are 4 ohm and 4 ohm are in series. So what will be its value? 4 into 4 by 8. So that means 2 ohm, 2 microfarad. Okay. So instead of this 4 I will consider a 2 microfarad capacitor in between this line. Okay, this line lo ee line lo 2 microfarad capacitor unnatuga I will assume. Okay, now I will identify each point, at each point what is the potential. Okay, so since it is A, so throughout this line A, so up to this point potential will be A, up to this point potential will be A, up to this point potential will be A, same potential line. Okay, now come from B, up to this point potential B, up to this point potential B, since it is straight line. So suddenly from A there is a capacitor, so next point will be something will be different. So let's say C. So ఈ లైన్ గుండా C వస్తుంది కాబట్టి ఈ పొటెన్షియల్ కూడా C. Okay, again this is a straight line, it is going up to this, so this potential is also C, up to this point is also C. See, we got 3 potential points. Okay, so can we write them A, C, B? Okay, because we have to find capacitance between A and B. So A to C, how many capacitors are there? We have to identify. See, A to C there is 1, and A to C there is 1. So ఈ 2 capacitors ni 1 capacitor అనుకున్నాం కదా, 2 micro. So 2 and 3, there are 3 capacitors in between A and C. Okay, each capacitor enta microfarad, 2 microfarad, 2 microfarad, 2 microfarad. Okay, now identify how many capacitors are there in between B and C. See, B and C ki madhya 1, B and C madhya 2. Okay, only 2. Okay, there are no other things. So this circuit will be, there are 2 capacitors between C and B, and each capacitance value anta 3 microfarad. 3 microfarad. Now find out. So this is in parallel, this is in parallel. After you find out equivalent, they will be in series. Okay, parallel formula em cheppanu, C1 plus C2 ante ikkada enta avutundi equivalent 6 plus, okay, 6 parallel, 6 microfarad parallel to 3 plus 3 enta 6. Okay, so both resistors are in parallel. Parallel formula you use this one. So 6 into 6 by 6 plus 6, 12. Okay, 6 2s are 2, 3s are, so answer will be 3 microfarad, right? So sorry, ikkada B value కనిపించట్లేదు, B value is 3 microfarad. Okay, so I will clear this diagram. For this answer is B, which is nothing but 3 microfarad. Okay, so answer is 3 microfarad. This is how you can do. So first you have to identify same different potential points, then you draw the equivalent equivalent diagram. Okay, so easy. So next one, next problem. Now this time they ask what is the equivalent resistance in cube lo resistors icharu, they are asking what is the equivalent resistance between A and B. So this is a little tricky question. So let me draw a cube here. I am just assuming that each line is some resistor. Okay, instead of keeping the resistors, I am just give you overall view. Okay, so let's say this is cube. Yeah, so this is Q. I'm not drawing the resistors value, but you assume that there is a resistor here. Okay, but at each point there is a resistor. Now this is point A. Okay, and this is the point B. So there are resistors also, but I'm not drawing here in this case. Okay, same figure, assume like this. Okay, now from A current is flowing. Okay, what happens at this point? it will divide equally. So let's say I1. So I will identify 1, 2, 3, 4 points. Okay, 5, let's 6, 7, and this point is 8. So there are 8 corners. Okay, so let's see what is happening to the current. Okay, so since current is coming, this will be divided into three equal parts: I1, I2, I3. Okay, I1 is along 1 and 2, I2 is along 1 and 6, I3 is along 1 and 4. Okay, so now at 2 what happens? This I1 will be divided again into two parts, that is 2 to 7, 2 to 3. Okay, this I1 will be divided into 2 to 7, 2 to 3 direction. Okay, now what happens to the I2 value at 6? At this point, this I2 will be divided into two equal parts again, 6 to 7 and 6 to 5. What happens to this current at this point? 4, it will divide it into two equal parts, 4 to 3 and 4 to 5. Okay, uh, that's how this current again, this 2 comes here and this 2 will come along this direction, these two directions will come like this. Okay, finally current enters through A, current leaves through B. Okay, so now what we have to do is we have to make a equivalent circuit. I will make a equivalent circuit here. You see very carefully. There are some points we need to. So point A. So this is the point 1. Let's say point 1. Point 1 నుంచి current is flowing in three different directions. Okay, I1, I2, I3 kada. So make three lines. Okay, there are three resistors here. Okay, so this is I1, I2, I3. Okay, so this is going from 1 to 2, I1. So this point is 2. Okay, and this point is 1 to 6. Okay, I2 is going along 1 to 6, and 1 to 3, 1 to 4, this point is 4. Okay, 1 to 4, I3 is going along 1 to 4. Okay, now come to the point 2. At point 2 what is happening? The same current is dividing into the two equal parts. So keep into two equal parts. Okay, so 2 to 7. So let's say this point is 7. Okay, 2 to 3, this point is 3. Now come to the point 6. 6 దగ్గర ఏమవుతుంది? Current is dividing along 6 to 7, 6 to 5. So make it divide into two equal parts. Okay, so 6 to 7, 6 to 7, 6 to 5. Okay, again at point 4 what is happening? It is dividing along these two directions, 3 to 5. So make it divide. So 4 to 3 and 4 to 5. Okay, see here the numbers are repeated. So wherever you are seeing the same numbers, just connect them. So this is 0.5 kada. So 7 to 7 I am connecting, and also 5 to 3 to 3 I am connected, 5 to 5 connected. Okay, so let me clear these diagrams. Okay, so these 3 points are nothing but, okay, so this is 7th point, this is 3rd point, this is 5th point. All will lie along a straight line. So if you draw them, 7, 3, 5 are same potential. Okay, same potential points. Okay, same potential. Similarly 2, 6, 4 will be same potential points. Okay, And now there is still remaining values are 3 to 8. 3 to 8, there is one resistor, okay, 3 to 8, and 5 to 8, there is one resistor, okay, and 7 to 8, this is 7 to 8, okay, there is 5 to 8, okay, so this is point, okay, 5 to 8. So you got it. These three are in parallel. These three are in parallel. So I will make simple diagram once again. So what happens is, sorry, here it is gone. So what is this? This one, there is one resistor. So these three are connected. Okay. So you see, first point 1. Okay. There are three resistors, right? So three resistors which are in parallel. Okay. So this is, they are connected to same potential points, that is called 2, 4, 6 points. They are all having same potential. So this is the 2, 4, 6 point. Again from 2, 4, 6. 1, 2, 3, 4, 5, 6. There are six resistors. So draw 6 lines. Okay. 1, 2, 3, 4, 5, 6. Okay. So 6 resistors are there. Okay. They are all connected to one point, same potential point, that is called this 7, 3, 5 points. Okay, this is 7, 3, 5 point. Okay, so again there are three capacitors which are in parallel. Three resistors are in parallel. So this is 8th point. See, now it's very easy to identify. These three are in parallel. These six are in parallel. These three are in parallel. So all are having same resistors. So I told you in resistors what happens, R1 R2 by R1 plus R2 kada. So ikkada equivalent resistance enta avutadi, R1 R2 R3 by ante R cube. How much this one? R1 R2 R3 by, means both three, sorry, let me erase this one. So three resistance are equal. So what will be the final value? R cube by, sorry, now what is the formula? Let me use this notice. Okay, so in series, R1 is equal to R1 plus R2. Okay, so in parallel, R1 R2 by R1 plus R2. Okay, what happens to this value? Find out, you will get 5 by 6 R. Okay, so that is how you can do. I think you can easily find out the value, because so R1 R2 R3 3. Okay, so you can find out, you will finally get R equivalent as 5 by 6 R. Okay, so these are all parallel, and once you got the equivalent resistance, they will be in series. You have to add them. Okay, so this is how you have to find the equivalent resistance formula. So answer is 5 by 6 R. Okay, so similarly, last problem of this session. So there are wires of equal resistance, which is 10 ohm, are joined together in the form of two pyramids, common base. If the current enters through A and leaves through B, then find the resistance between points A and A. So this is nothing but equivalent resistance. So you have to use the symmetry method. Okay. So if you draw this symmetry, let me use this annotation. Okay. So this is the symmetry axis, because exactly this part looks like the same. Okay. So according to the symmetry thing, what we assume, along the symmetry axis potential will be the same. Okay, so let's say this is the C point is the symmetry. So from A, how many are there? There are 4 lines, each is having 10 equivalent resistance, 10 10. Okay, so this point is again C, all are connected to the C, and like they are in a parallel connection. Okay, so let's say this point is C. Okay, from C to B again they are in parallel. How many are there? 4. Okay, so find out the answer. You will get finally 5. So each value is 10 ohm. Okay, so you will get the answer as 5 ohm. So I am not doing here because you can do, because they are in parallel connection, they are in parallel, and once you got the equivalent resistance here, equivalent resistance, you have to just add them. Okay, because they will be in series. Okay, you will get finally answer as 5 ohm. I'm not doing here, you can do just very simple math. Okay, thank you everyone. Maybe next class I will come up with some tricks on Gauss theorem, like when charge is placed inside the cube, what will be the net electric flux if it is placed at the one corner, and when it is placed at one side of the cube, what happens to the electric flux. So we will see in next video some tricks on charge placed inside the cube, what will be the net flux coming out of the cube. Okay, after that we will make so many videos based on your interest. If you ask any concept, any problems, I will solve. So please comment on the comment section, so that I can make videos for your purpose. Okay, thank you very much. If you have any doubts, just write them in comment section. Thank you.